In the previous video, we looked at two-dimensional vectors. Now look at the three-dimensional vectors. Three-dimensional vectors basically are nothing but a vector represented in 3 dimensions. So till now we had 2 axes which were x and y, but let's say we have 3 axes which is like this, where this is our x axis, this is our y axis, and this is our z axis. Now we could have a vector that is represented on all 3 axes, and that's basically a 3-dimensional vector, and it would generally be represented as if there is a 3-dimensional vector A, we would represent it as A cos alpha I plus A cos beta j plus A cos gamma k. Now I, j and k represent unit vector across these axes. So I is across x axis, j is across y axis, and k is across z axis, and alpha, beta, gamma are the angles of that vector from each of those axes. So just to understand, if we reduce it to a 2-dimensional vector, we could generically represent using this. So for example, if we take a 2-dimensional axis, let's say this is our 2-dimensional axis, and let's say this is our vector. Let's say this is our vector and this is the angle theta. So the angle from the, if theta is the angle from x axis, in case of a 2-dimensional vector, angle from the y axis will be 90 minus theta, because it is only in 2 dimension. So this vector A will become A cos theta I plus A cos 90 minus theta j, which is nothing but A cos theta I plus A sin theta j, which is what we learned in the previous lecture, so previous video. So as we can understand, the generic representation is this. So let's rewrite it again. A vector A can be represented as A cos alpha I plus A cos beta j plus A cos gamma k, where alpha, beta and gamma are the angles from axis x, y and z respectively. A is the magnitude of the vector, and so this is our generic representation of a vector. Now once we have this, we can do some interesting things. For example, if we had to add 2 vectors, we could just add their I, j, k components. So let's say for simplicity sake, we write A cos alpha as Ax, which is the component across x axis, A cos beta as Ay, and A cos gamma as Az. So let's say we have a vector A, which is Axi plus Ayj plus Azk. Then we have another vector B, which is Bxi plus Byj plus Bzk. So A plus B can be written as Ax plus Bx I plus Ay plus By j plus Az plus Bz k. So this makes it very simple to add vectors algebraically, which is very useful in complex problems. Now let us look at a problem. There is a problem with, let us say, it says that there is a force of, let us say, 16 newtons that acts on a particle along a direction making an angle of 45 degrees with the vertical. So let us draw our axis again. So this is a two dimensional problem, so we can just have two dimensional coordinate system. So this is our two dimensional coordinate system. Now what it is saying is that there is a particle here and there is a force acting on it which makes an angle of 45 degrees with the vertical. So let us draw a, let us say this is the particle and this is the force that is acting on it, and the angle is 45 degrees with vertical. Now what it is saying is, what is the component of the force in the vertical direction for this. Now we know that there are two ways to do it. One is using the general method. So if you look at the general method, where we have already defined A is equal to A cos alpha I plus A cos beta j plus A cos gamma k. Now if the angle, so the component of this particular force across each of the axes would be A into, and the force is, let us say, 16 Newton. So the component across each of these axes would be nothing but the magnitude into the angle with that axis. Now here, since we are already given the axis with the, we are already given the axis with the vertical angle with the vertical axis, so we can safely say that the component across y, which will be Ay, will be equal to 16 into cos of 45 degrees, which we can solve and get the answer. If we were asked the component across x axis, we can easily see that the angle with x axis is also going to be the same. So it will be 16 cos 45. The component across z axis does not exist, because it is this question seems to imply that it is a two dimensional coordinate system that we are working with. Otherwise we could have found it out. So now with that, we already talked about how do you add multiple vectors. The only thing that is left now is, how do we find out the magnitude and the angle of addition of a vector. So now let us see, if we have two vectors which are A and B, and very similar to what we have found, so if there is a special case of two vectors where the coordinate system is, let's say we have vectors which are in two dimensional space. So, there we basically have A is equal to AXI plus AYJ, B is equal to BXI plus BYJ, and C is equal to CXI plus CYJ. And now, in this particular case, if we, let us say, wanted to find if we want to find the sum of these three vectors, that will be, so A plus B plus C is nothing but AX plus BX plus CX I plus AY plus BY plus CY j. Now, if you look at these two vectors, if you look at this resultant vector, we can see this resultant vector as nothing but a sum of two perpendicular vectors, one which is AX plus BX plus CX in the x axis direction, and the second with so this particular one is a, if you look at this one, this is x axis and this is another vector which is in the y axis, and any vector along the x axis will be perpendicular to any other vector along y axis. So, if we wanted to find their resultant magnitude, so the magnitude would be nothing but square root of AX plus BX plus CX whole square plus AY plus BY plus CY whole square. So, now we know the magnitude of the resultant vector. If we want to find the angle that resultant vector makes from the x axis, we can figure it out this way. So, as we have already said that the resultant vector is nothing but a vector, it is a sum of two vectors along x axis and y axis, and the x axis vector is AX plus BX plus CX, and the vector on y axis is AY plus BY plus CY. Now, let us assume the resultant vector was something like that, and we had to find this angle theta. We know that tan theta is nothing but AY plus BY plus CY divided by AX plus BX plus CX. This is nothing, this is very simple that you can get out of trigonometry. Basically, the tan theta is nothing but the length of the perpendicular divided by the length of the base. So, this is our angle of the resultant vector from x axis. Now that we have that, let us look at, we have the addition. We know that subtraction is nothing but addition of a negative vector. So, if we have two vectors and we want to subtract them, take the second vector, change its direction, and that will essentially give you the, and then add those two vectors, that will give you the subtraction. So, just to understand it, I think we did this in previous session as well. Let's say these are our x and y axis, and let's say we have a vector which is this. Let's say this is our one vector, and let's say, let me draw it in slightly different ink. So, this is our first vector. Now, we want to draw another vector. Let's say that one was, another vector is this. Let's say this is the second vector. let us say this is the second vector. Now if you want to add it, the life is very simple. We can just draw the third line of the, we can just, let us say we take another color, let us say this is this blue, and if you wanted to add these, addition would be nothing but this particular vector. But let us say we want to subtract it. If you want to subtract it, what we essentially have to do is take this. So let us say this is the vector A and this is the vector B. What we have to do is we have to take the vector B and reverse its direction. So the vector in opposite direction will be something like this. So this is our opposite direction vector, and now because it is opposite direction, the subtraction of this can now be found like this. So this is going to be, so this becomes minus b and this becomes a minus b, and this is a plus b. So same way, if you were given a vector which is, let us say we have a vector which is the magnitude A is 10 and the angle, let us say we have a magnitude 10, magnitude B is equal to 7, and the angle of the vector A, the so let us say the vector A is along x axis. So this is our vector A, and let us say our vector B is along an angle theta. So this is an angle theta, this is 10, this is 7. Now ideally if we wanted to take their addition, what we would essentially end up doing is we will to find the magnitude, we will, the vector A is nothing but vector A. So we can take the vector B and write it as its components. So vector B would become 7 cos theta I plus 7 sin theta j. So that is how we have broken it up, and now if we wanted to add them up, we could add them by this essentially is going to become 7 cos theta plus 10 because other vector is in the same direction, plus 7 sin theta. And now if you wanted the magnitude of it, we know the magnitude will be square root of I in the factor that is multiplying I, the magnitude on I direction, and the square of the magnitude in j direction. So the magnitude of A plus B would be nothing but square root of 7 cos theta plus 10 square plus 7 sin theta square. So now if we open it up, we are essentially going to get 49 cos square theta plus 100 plus 140 cos theta plus 49 sin square theta. So 49 cos square theta plus 49 sin square theta will become 1. So what we have is 49 plus 100 plus 140 cos theta, and it's actually nothing but if you are looking for a generic formula, the generic formula is nothing but the sum of, if you have a vector A and a vector B with the angle theta between them, the magnitude of A plus magnitude of B is nothing but square root of, if you take A along the x axis, so it will be A square. So, it will basically become A plus B cos theta whole square plus B sin theta whole square. So, which this will become A square plus B square cos square theta plus 2 AB cos theta plus B square sin square theta. Now, B square sin square theta and B square cos square theta will become B square. So, this becomes A square plus B square plus 2 AB cos theta, and we forgot the square root here, as well. So, this is the generic formula. If you have two vectors A and B with an angle theta between them and we add them and we want the magnitude of them, it is going to be this. Similarly, we can work out, and the angle tan theta, tan alpha of the resultant vector will be B sin theta upon A plus B cos theta. Now, this is the angle, because we assumed vector A to be along x axis. This is essentially angle from the first vector, because that, if you change that will also change. So, now we have figured this out. Let us go to the dot product or the scalar product. So, when we want to multiply two vectors, unlike addition, there are two ways of multiplying a vector. One is called a dot product, which is also called a scalar product, and scalar product is nothing but it is a scalar quantity. It does not have direction, it is just a value. And the second one is cross product, which is basically the which is nothing but the what you call the vector quantity. So, let us talk about the dot product first. So, let us say dot product. So, let us look at some basics of dot product. When we are talking about dot product, dot product for two perpendicular vectors will be 0. So, for example, the dot product of a unit vector across I and j will be 0, which will also be j dot k, this will also be 0, on k dot I, this will also be 0. So, the dot product across two perpendicular vectors is going to be 0. That is one important thing to understand. How do we get it? Dot product across two vectors is nothing but vector A dot vector B is nothing but magnitude of vector A into magnitude of vector B into cos of angle. So, perpendicular vector theta is 90, and because of that A dot B will be 0 if theta is 90. Now, once we know that, we can take any generic vector. Let us say we have a vector A which has three components, AXI plus AYJ plus AZK. This is our first vector, and we have second vector b, which is bxi plus byj plus bzk, and if we take a dot product of these, it's just very similar to a mathematical multiplication. So, it will basically become ax bx I dot I plus ay bx I dot j plus az bx I dot k, and similarly we will have plus ax by I dot j plus ay by j dot j plus az by k dot j plus az bx I dot k plus ay bz j dot k plus az bz k dot k. Now, from the previous explanation, if the angle is 90 degree, they will be 0. So, all the I dot j, I dot k, they will become 0. So, we only are left with these three quantities, which is I dot I, j dot j and k dot k, and we also know it is a b cos theta, because theta is 0, it is going to be 1. So, I dot I will be 1, j dot j will be 1 and k dot k will be 1. So, the multiplication of these two vectors is ax bx plus ay by plus az bz. This is basically the generic formula of a dot b, and this is also known as the dot product of two vectors. Now, let us get to the cross product. Now, the cross product, as we have already talked about, the result of a cross product is a vector itself, unlike the dot product. The dot product, the result is a scalar, the result of a cross product is a vector, and the fundamental formula is, if you have two vector A cross B, then the result is equal to a b sin theta. Now, as we can see, for theta equal to 0, this will be 0. So, I dot I cross I will be 0, j cross j will be equal to 0 and k cross k will be equal to 0. The other thing that we need to understand is that for cross products, the cross product of perpendicular vectors will be orthogonal to both of them. What that really means is that I cross j will be k, j cross k will be equal to I and k cross I will be equal to j. This result is essentially obtained by what is actually called the right hand rule of vectors. Now, what is the right hand rule of the vectors? It is actually very simple. Let us say we have a Let us say we have a two-dimensional space. Let us say this is our two-dimensional space. So let us say this is our axis system. This is our one vector which is A, and this is our another vector which is B. Now what we need to do is, if we put our hand, which is this is vector B. So let us say this is how we put our hand, and this is our thumb pointing up, and this fingers direction, fingers are wrapping in this direction. This is essentially the direction in which we are going to measure the angle. So if we do A cross B, this is the angle theta measured in this direction, in the direction of fingers wrapped. We are wrapping fingers inside. Then the resultant vector will be in the direction of our thumb. So if this was our direction x, A was representing x and B was y, the z would be where the resultant vector will be pointing to. And there are multiple systems, but this is something that is very easy to understand. So basically this is called right hand system, and the point here is, once you choose a system you follow that system. So if you are following right hand system, we follow right hand system everywhere else. So from that you can see, if we are doing A cross B, where we put our hand on the vector A with fingers wrapped in the direction of the angle, then the resultant vector will be in the direction z. But let us say we want to do B cross A. If we want to do B cross A, and we have to, so we either have to put our thumb downwards. If we want to measure the angle, if we put our hand on vector B and we want to measure our direction, we want to measure the direction of angle like this. So that is one way. So then we know the direction would be in the downward direction, which will be opposite to z. Or if we want to keep our hand the same way that we are keeping now, then we measure this angle, which will essentially become 360 minus theta, because we are coming at that angle in the opposite direction. So basically the point here is, A cross B is not same as B cross A. B cross A cross B will be equal to minus B cross A, because the angle direction changes. When we want to measure B cross A, the resultant vector will always be in opposite direction. So this is one rule that we need to understand. So now with that, there are few other rules with cross product. So one we have already talked about, A cross B equal to minus B cross A. Then there is a distributive law, which is A cross B cross C is equal to A cross B plus B cross C, and then we have the associative law, which is A cross B cross C equal to A cross B cross C. So now we understand the cross product. Now let us see what we have is, we are given a vector which is, let us say 10, the magnitude of A is 10, magnitude of B is 12, and the cross product is, let us say the cross product is given, which is, let us say 18, and we are told find the angle. So, now we know that magnitude of A cross B is equal to AB sin theta. So, sin theta is equal to, let us say this was 18 upon 10 into 12, and then we can find the theta that way. Now, if you want to find the generic formula of the cross product of two vectors, so we can do that. AXI plus BXJ plus, no, I always get confused with it. AXI plus AYJ plus AZK, B is equal to BXI plus BYJ plus BZK, and now we know, as we have already talked about, I cross j will become k, I cross I will become 0. So, once we multiply, let us take AXI first and we multiply it with B. So, once we multiplied AXI with BXI, we are going to get 0. When we multiply AX with BY, it will become I cross j. So, resultant will be k. So, we get AX BYK. Then we multiply AX with BZ, and we get I cross k, and now we know that k cross I is j. So, I cross k will be minus j. So, this becomes minus j. So, plus, similarly we take AY, j cross I will be minus. So, we can say minus AY BX j, not j, this will be k. Then AY BY will be 0, AY VZ is JK. So, the resultant will be I. So, we can say AY BZ I. Then we go to AZ, KI will become J. So, AZ BX J plus KJ will become minus I. So, it becomes AZ BY minus I. So, now we can collect them together. This is a I term, this is a I term. So, AY BZ minus AZ BY I plus, let us say, J term AZ BX minus AX BZ J, and then K will be AX BY minus AY BX K. So, this is the generic formula for the cross product. If you ever need to use it, I just find it easier to always multiply them, but yeah, if you want to do quick multiplication, you can use this formula. Cross product. Now, let us talk about something called a 0 vector. We know that if we have two vectors which have equal magnitude and opposite direction, then their addition will be 0. So, if we have a vector A I and another vector which is A minus I, they will be 0. And so, if you want to draw it, if you have, let us say this is our axis, let us say this is one vector we have, and then this is another vector we have. The sum total of A and B will be 0 because they are same magnitude and opposite direction. Similarly, when we multiply any vector with a 0 vector, the result will be 0 vector, and if we add 0 vector to anything, result will be the same thing. So, if we have a vector A plus 0 vector, the result will be A and if we have a cross 0 vector, the result will be 0 vector. And if we have any number which is, let us say, k, and we multiply 0 vector with it, we will essentially get a 0 vector back. So, that is basically, I think that is the end of the complete vector algebra. So, we can look at, we can try doing some questions, because this is a kind of a very important part which is used in many places. So, for example, let us say we have a question that says, let us say we have a vector A that is nothing but 2I plus 3j plus 4k, and we have another vector B which is 4I plus 3j plus 2k. Now, we have to find the angle. So, what we can do is we can find the dot product of these two vectors. So, A dot B is nothing but, we know Ax Bx, so 2 4s are 8 plus 9 plus 2 . Oh, this is 4k. So, this becomes 2 into 4, so 2 4s are 8. So, this is 4k, so this is 8. So, the A dot B is 25. Now, we have to find the magnitude of A. So, magnitude of A is nothing but the square root of Ax square plus Bx square, Ax square plus Ay square plus Az square. So, which is equal to 4 plus 9 plus 16. So, that is equal to square root of 29. Similarly, we have to find the square root of B, which is nothing but, the magnitude of B, which is nothing but 16 plus 9 plus 4, which is again square root of 29. So, now if you have to find the angle, we know A dot B is equal to AB cos theta. So, cos theta is equal to 25 divided by square root of 29 into square root of 29, which is equal to 25 by 29, and theta will be nothing but cos inverse 25 by 29. So, this is one type of question that you might get. Then there may be simple things like you might be asked to do some arithmetic, like find A dot B cross C and stuff like that, which you should be able to do. Now, there are some other things that you might want to have a look at, that is some kind of proofs. So, for example, one type of question might be, if magnitude of A plus B is equal to magnitude of A minus B, then prove that A is perpendicular to B. Now, we know that the dot product of perpendicular vectors is 0. So, one way to solve this problem would be to look at a vector that is A dot B. So, let us say we say vector A minus B, this is one vector, and so we take we take vector A plus B, the magnitude square, that we can simplify to the dot product of A plus B with itself, because we know if we have a vector A, let us say we have a vector A which is AXI plus AYJ plus AZK. If we take a dot product of A dot A, we know it will become AX square. So, which is nothing but the magnitude of A into A. So, what we can do is we can say magnitude of a vector is nothing but the dot product of that vector with itself. So, this we can do A plus B dot A plus B, and once we do the dot product, what we will have is A square plus B square plus 2 A dot B. Now, what we want to do is we want to do the same thing with A minus B whole square. So, we take A minus B, this is another vector, we take whole square, this is nothing but A minus B dot A minus B. So, here we get A square plus B square minus 2 A dot B. Now, we are given that A plus B is equal to A minus B. That means that this and this are equal. That means A dot B is equal to 0. And if A dot B is equal to 0, we know that for A dot B equal to 0, A has to be perpendicular to B. So, this is like one way we can prove it. So, I think I am going to stop here. This is basically the I think the end of everything about vectors, and in the next video we will continue with the next bit. Thank you.